Good day, students. Welcome to a clip on how to find the length of an arc. And in some problems, we're going to go over examples on how to convert degree to radian measure, okay? That will enable us to use the formula. So before we start, we're going to talk about the formula we're going to use for the examples, and then we'll take a look at some examples after that, okay? So we're going to start by writing down the formula. So what is the formula for arc length? Formula for arc length, for length of an arc. The formula for arc length is basically L equals, S equals r theta. Okay, so it's S equals r theta. Okay, and then let me draw a circle for you. If you have a circle like this, um, the arc length is basically a portion of the circle. So let's say this is theta right here. This is theta, and this is the radius, which is uniform. Then this portion subtended by that angle right there, that's S. Okay, that's S, and is given by r theta. Okay, so how on earth did this formula come about? Well, if we think about it, we know that the circumference of a circle is 2 pi r, right? Well, how did this happen? Well, we know that the ratio let me derive this for you real quick. We know that the ratio of the circumference to the diameter of a circle is always pi. So any circle at all, if you divide the distance around the circle, the circumference, by the diameter, you're going to end up with pi. Okay, so if you pick up a CD, for example, you measure the distance around it and divide it by the diameter, you're going to end up with 3.14 or something of that nature. Okay, so this is a relationship between the circumference, the diameter, and pi. So, but we also know that the diameter is equal to twice the radius, right? So if I substitute that fact here, I'm going to know that the circumference divided by twice the radius is equal to pi. Okay, that tells me that to get c by itself, the circumference, I'll multiply both sides by 2r and 2r. So I'm going to have the formula c equals 2 pi r. Okay, so that's where the circumference formula came from, c equals 2 pi r. All right, so the question now is, what is the angular measure for the circumference of a circle? When you're finding the circumference, what is the central angle? Well, when you're measuring the circumference of when you're measuring the circumference or calculating the circumference of a circle, the central angle is full circle. You go all the way around, which is 360 degrees or 2 pi. Okay, that's the theta in this case. So for this problem, theta is actually 2 pi. Okay, and then the radius is r. So the question is, what if we don't want to do full circle? What if we just wanted to do a portion of the circle, let's say from here to here, and then we call it theta, for example? So what do? So instead of you using c is equal to 2 pi, you see this 2 pi right here? This 2 pi basically means full circle. But if you're not going full circle, whatever the angle is, that is what will replace 2 pi. So let's say we're pi, you replace this with pi. If it were, let me use some examples. Let's say if theta were pi, then we're going to have S, arc length, equals, instead of 2 pi, we're going to replace the 2 pi with pi and r. Okay? If theta were pi over 4, that's going to be a fourth of, this is half of a circle though. If theta were pi over 4, we're going to use S equals, instead of 2 pi, we're going to use pi over 4r. Okay? So whatever theta is, that's what determines what this angular component is. Okay? So in essence, this arc length f is equal to r times theta. When theta is 2 pi, is exactly the same as the c formula. Okay, so this formula right here, this circumference formula, is a special case of the arc length formula. It is when theta is equal to 2 pi when doing full circle. Okay, so that's where this formula came from. So S is equal to r theta is actually an offset of this, a component or a derivation of this formula. C is equal to 2 pi r. All right, so this is the formula we're going to be using for today, just look at it as the portion. We're just taking a portion of the circumference. Let theta be the determiner of the portion of the circumference that we're taking, okay? All right, so let's take a look at question number 1. It says find the length of each arc. So in this case, we know that the formula we're using is S equals R theta. All we need is R and theta, okay? So R is the radius, is 14 feet. And theta is the angle of the arc length, which is 3 pi over 4. Notice that when I was showing the example just now, my derivation was in radian, right? I was using 2 pi, this is in radians. So your angular measure must be in radians if you want to use this formula right here, okay? So remember, theta in radians. If it's not in radians, then you have to convert. It is, so we don't have a problem, all right? So the arc length is going to be R theta, which is 14 times 3 over 4 pi, or 3 pi over 4. Put this over 1, we can multiply across. We're going to have 42 pi over 4. And 2 goes into both of them, divide by 2. And then we're going to have 21 pi over 4 feet as, I'm sorry, over 2, because we're dividing top and bottom by 2, over 2 feet as our arc length, okay? So arc length is 21 pi over 2. Our answer is option C. So basically what this answer means is that the distance from here all the way to here is exactly 21 pi over 4 feet, okay? This distance right here, that's what the arc length is. All right, let's take a look at question number 2. This looks like 3/4 of a circle. We're going to use the same formula. S is equal to R theta. So in this case, R is 11, and theta is already in radian, which is 3 pi over 2, which is excellent. So let's go ahead and find the arc length. So S is going to be R, which is 11, theta, which is 3 pi over 2, okay? All right, put this over 1, we're going to cross multiply. We're going to have 33 pi over 2 centimeters as our arc length, okay? So the answer is C. So 3/4 of the extremity of the circle, so this portion right here, let me use a different color. This portion right here, the distance from here all the way to there is basically 33 pi over 2 as the arc length. Okay? All right, let's move on to question number 3. R is 18 inches and theta is 150 degrees. We're using the formula S is equal to R theta. The radius is 8 inches. But what is theta though? Theta is 150 degrees, that's no good. Remember, theta has to be in radians. Theta in radians in order for you to use this formula, okay? So we need some work to do. We need to convert 150 degrees to radians. So how do we do that? We just simply multiply by this equivalent relationship. We know that pi and 180 are exactly the same thing, right? So multiply 150 by pi over 180 degrees. This conversion factor would change 150 degrees into radians, okay? So if we multiply this across, we have 150 pi. The degrees cancel out over 180. We can divide by 10, which eliminates the zeros. So we have 15 over 18 pi. And then we can divide by 3 top and bottom. And that leaves us with the angular measure theta is going to be 5 over 6 pi. So this is the theta that is consistent with the requirements for using this formula, which is a radian angular measure, okay? So remember, you cannot just plug in the degree into the formula, you have to convert first. All right, so let's go ahead and find out what the arc length is. So it's going to be r theta, which is 8 times 5 over 6 pi. All right, this becomes 40 pi over 6. Divide top and bottom by 2. And then you're going to have 20 pi over 3 inches as your arc length. So your answer is D. Okay. All right, let's move on to question number 4. r is 17 feet and theta is 225 degrees. We know the formula S is equal to r theta. R is 17. Theta is, uh-oh, we have a problem. Remember, theta has to be in radians in order to use this formula. Theta is in degrees here, so we must convert, okay? So 225 degrees, we're going to multiply by the conversion factor, which is pi over 180 degrees. We know 180 degrees and pi are the same, so what I'm doing here is I'm just multiplying by 1, but this formula, version of 1 actually converts this number conveniently for me, okay? So the degrees cancel out. Multiplying across, we're going to have 225 pi over 180. And then we're going to divide top and bottom by, let's see, we can reduce it by 45. So we can divide top and bottom by 45. So divided top by 45 and the bottom by 45. And then that's going to leave us with the angular measure, theta. Theta is going to be 5 pi over 4 in radians, okay? So theta is 5 pi over 4, so this is the exact measure we want in order for us to be able to use this formula, okay? Remember, theta has to be in radians. Alright, so let's figure out what the arc length is. The arc length S is r theta. R is 17. 17 times 5 pi over 4. Multiply across, we'll have 35 plus 50, which is 85 pi over 4 feet as our arc length, and the answer is option B. Alright, let's move on to the next question, the last one. R theta. So S is equal to r theta. The radius is 12 centimeters. And theta needs conversion because it's in degree measure, okay? So let's go ahead and convert that. 270 degrees. Sorry, I'm calling. Change it. So 270 degrees. We want to change this into radians. So multiplied by the conversion factor, a version of 1 that changes this. So basically pi over 180 degrees. We do that for us. This is 1, okay? So we're not changing the angle. Alright, so thetas cancel out, and then we can multiply across. We get 270 pi over 180. And you can divide by 10, which takes out the zeros. That gives you 27 pi over 18. And then we divide top and bottom by 3. And then actually we can divide by 9. I think 9 is a better option to use. Divide by 9 so we save time, okay? So 9 is the greatest common factor. Divide by 9 top and bottom. And that leaves us with theta equals 3 pi over 2. Alright, so theta is 3 pi over 2. Now we're ready to use the formula because our angular measure is in radians, okay? So this arc length S is equal to 12 times 3 pi over 2. We'll multiply across, we'll have 36 pi over 2. And then we'll divide, we'll have 18 pi units is in centimeters. So this is the arc length of the circle with radius 12 and angle subtended. And the angle subtended is 270 degrees, okay? So there goes your answer. Alright. So thanks so much for watching this presentation. Please subscribe to my videos for more worksheets on solving mathematics. You can also feel free to request videos. More videos can be found on math.serve.com. Thanks again and have a wonderful day.